Hello, I'm Tom Hollingsworth, and this is Networking Field Day 13. We are here in sunny Silicon Valley, California, with SolarWinds. You are about to watch a presentation featuring SolarWinds and their unique solutions and products, along with a group of delegates around the table who represent the best and brightest in the networking industry. They have been invited to ask questions, make comments, and offer their opinion, and represent the networking community at large. If you would like to know more about Tech Field Day, including how to become a delegate or how to become a sponsor of this event, please go to our website at techfieldday.com. If you would like to see more videos like this about a wide range of technology subjects, please check out our YouTube channel at youtube.com/techfieldday.
This is a brief section. It's just another thing we're thinking about in terms of how network monitoring evolves, and I sort of want to get your opinion about it. So the problem is, like, you have all of these networks, right? Networks look something like this in a ridiculous, oversimplified view. You've got branch offices, they connect to the internet, they connect to each other. Sometimes you have redundancy, sometimes you don't. You have a lot more access devices, but in general, routers and switches and access points provide transit, right? You also see more and more of these devices over the past 10 years, which is load balancers, firewalls, WAN optimizers, web proxies. Now these things often, mostly, I don't know, I'm curious what you guys think about that as well, but oftentimes they're administrated and the network team is responsible for them, right? So the interesting thing to me about these devices is that they're relatively few in the network. So they don't get a lot of attention from monitoring, including from SolarWinds. I don't think SolarWinds has given them enough attention. We monitor your routers and switches and access points. We monitor these devices too, but we don't go as deep. And we tend to use metrics that are sort of similar to routers and switches. That's kind of weird. And the reason that we did that is simple, is there's not very many of these devices. Right? There's not very many of these devices. The problem is these devices are really, really important. They're tend to be at bottlenecks of your network. So for example, if the firewall out to the internet goes down, your internet's down. Like, that's a different degree of problem than if your switch is down. If you put a load balancer in place and you go to F5 and say, hey, I'm willing to spend $100,000 to get redundant load balancers from you, it's because the application behind that load balancer is super critical to your business. And generally, all the applications behind your load balancer are really important. So if your load balancers all go down, heaven forbid, then that's a catastrophic event, right? So even though these devices are few in number, they're incredibly important and they're complex, right? They're doing data manipulation that tends to be beyond what a router or switch or even a firewall is going to do to your packets. So they have complex configuration, they have complex ways in which they interact with the data. They're few in number, but they're very critical. So we need to do a good job of monitoring these components. And if you look at a switch, you monitor things like CPU, memory, interface bandwidth. These are like the holy trinity for switches and routers as well. You need to know CPU, memory, interface bandwidth, interface error count, right? This over and over for all of your switches. When you look at load, go ahead.
And discards.
Discards, errors and discards, yes. When you look at load balancers, it's a very different picture, right? Because load balancing can only be delivered through this sort of distributed architecture. It's the nature of load balancers. You have DNS load balancers at the top, whether it's Cisco, GSS, long live, or NetScaler, or a GLB from F5, you have something responding to DNS. Those distribute to your traditional load balancers, which actually take in the traffic from the end user and distribute it to servers below. That actually is architected through a bunch of logical entities, virtual servers, pools, pool members, all of this sort of stuff. And so this is a very different picture, and the data points that you care about in your load balancing are necessarily different than your routers and switches. So if you forklift the data set that you have for your routers and switches and put it on your load balancers, you're not looking at the right things to understand the health and performance of your load balancers. So we built a very relational view. In SolarWinds. If I can remember the URL, I think actually I'll just use this guy to monitor specifically F5 load balancers. So this unfortunately requires a big commitment into deep diving and monitoring a lot about a single platform. So this is our load balancing dashboard, and you may notice that this is different from any other screen you see in Orion and NPM. And it's very relational by nature. So you can see your services at the top because these are the things that matter the most, even though they're logical things, right? And for this service to work, it depends on global traffic managers, local traffic managers, virtual service pools, and pool members. And if you select these, you can show the relationship and understand that this service is powered by a specific global traffic manager and an HA pair. He has a local traffic manager, a virtual server. There's a single pool, and that depends on 2 pool members. And of course, each of these components perform a separate function, so you should have the right data for that. So this is a service that's down. It's down because there's no enabled pools available. It's getting 5 requests per second. If we look at the pools, which are mapped out automatically here, then we can see that this is a pool. That's the name of the pool. Status is down. It's down because the children pool members are down. Makes sense. It's still receiving 8,200 connections. If we look at the individual pool members, we can see the status is down because it's unable to connect. And if we drill down further, we can see the specific health monitor, its name, and why it thinks that pool member is dead. Right? So it's basically the right data at the right pieces presented in a way that makes it easy to understand the health and performance of that sort of class of device, load balancer, WAN optimizer, or whatever.
I like the display. My question would be, how would you determine thresholds when it's in trouble?
I think it depends on the device. For F5, we got lucky as a lot of their thresholds are something they determine themselves. One of the unique things about load balancers is it almost doesn't matter if you think it's healthy or not. If the load balancer doesn't think it's healthy, it will take it out of the pool and then it's not healthy, right? So they have built-in thresholds and we use that.
I was thinking more capacity of the box, which I see it in the context of firewalls and IDSs, where I think a lot of the vendors are maybe a little bit less than candid about when their box is overloaded. Some vendors will tell you at most this many VPN tunnels or stuff like that.
Yep.
But some of the firewall vendors, in particular, CPU and number of flows and NAT points,
yes,
is
absolutely.
kind of squishy.
So when you separate from the individual services and you think about the platform, the hardware platform, you have to be thinking what's the right question to ask. So here, for example, for global traffic managers, we tend to focus on requests per second, which is DNS, whereas local traffic managers, we think about connections. Right now, you specify the thresholds manually for those. But for a firewall, it may be new flows created per second, or total flows. How much con state do I have to keep track of? So that's sort of how we're thinking, and of course you can click on any of these and drill down and get sort of the right data set for that component, and the little relationships will follow you so you can navigate around and use that to jump around in your infrastructure. So that's sort of how we're thinking about that in the context of F5s. It's a framework though, right? Like I think we need to do this for all of the really important classes of devices outside of routers, switches, and access points that we have always covered well. So every time we see a gap, firewalls definitely a gap, we ask ourselves, how does an engineer assess the health and performance of this component? Does he look at the CPU or does he look at the flow count, right? So we need to intelligently select the right data set and present a picture that makes sense for the purpose or the role of that device. We also, of course, need to think about troubleshooting.
Brian, are you doing the same data enrichment in Network Insight, with F5 that you're kind of doing with the routers? You're monitoring the routers in NPM, and so you're able to, add the configuration had changed or this link is overutilized. Are you doing the same thing in servers where, you saw that the pool member is down and you're able to then just drill in directly into that server to see it had a power supply failure or disk failure?
Yes, you can absolutely link over. Now we treat the F5 as authoritative in terms of what it thinks about those components because it makes it happen by pulling something out of a pool. So we tend to present F5's view, but we will allow you to drill over. And a question of what devices deserve this coverage. Any specific devices you guys can think of that, you go in there and CPU and RAM and interface stats and that's not what you want? Anyone have anything leap to mind? Cool. Well, we're totally going to build support for a bunch of devices anyway. If you are aware of any visibility gaps, and particularly with you guys, where it's less about your specific environment and more about sort of your industry perspective of how's monitoring doing, where is monitoring not paying enough attention, I would love to know. Please email me.
So I do have one challenge.
Great.
For in a data center where you have things like transparent firewalls or overlay transport virtualization, these things are always very difficult to monitor and put into your path, and they're almost invisible. So
Yeah.
having some capability to put that in the path or get that information, even if it's just CPU memory, interface statistics, and placing that in the path so you can see, okay, it's going through a firewall, and that firewall context, which is transparent, is having issues or something.
Yep. It's a good observation. I think sort of underlying that is what you see with the paths is all layer 3. So if you have 2 layer 3 nodes and then you have a layer 2 node or transparent or something in the middle, then we don't show that. So I don't know what the right solution is there. Manual, as you specified, that's the best thing I've come up with. The question is, how do you measure the impact on each side such that you can do isolation, problem isolation? I absolutely think that's a gap. I agree.
Even companies that do firewall management, like third-party companies, I won't name any, but even they have challenge putting transparent firewalls in their solutions, in their paths.
Yeah, absolutely.
So it's just an interesting thing that someone's eventually going to solve, and it'll be really helpful.
Yeah,
I consider it to be a design problem.
Well,
I just don't do that because I've been burned too many times by people forgetting to tell me, oh, there's an IPS in that link. And it turns out that's the performance problem.
yeah, I mean, layer 2 as a whole,
So
it's
visibility
supposed to be
would really help.
transparent. So very difficult to measure sometimes.
But I think the overlay question is something that's very interesting, right? Because we're moving into a world that's largely built on overlays. Right? You've got the XLAN overlays or other overlays in the data center environment. Everybody's moving toward SD-WAN, which is largely overlay-based technologies, right? So what are you doing to look at both the overlay and the underlay there? Right? Because both are a part of the topology.
Right, I agree. I mean, it's different layers of the same topology.
Right.
We already had layer 1 and layer 2 and layer 3, so now this is
The other layer 2,
now.
or the other layer 3.
Yeah, sure. Right. I think that's most accurate. Right. It's something I don't think we have solved well today. I totally agree. I think there's a lot of room there. I think we should be doing more. I don't know exactly what it looks like yet. We've talked to a lot of customers that have overlay or SDM deployed in a lab or in limited production capacity, even some that are using NPM specifically to monitor. And when we talk to them, they've told us, NPM, it's still monitoring my transit layer, and that's still important, right? And necessarily when they're doing a new overlay, the vendor that's providing the overlay, they provide a lot of tooling for visualization. Cisco ACI, for example, visualizes that overlay. So I haven't figured out exactly where those mesh. Right now it seems like both are necessary, but I think they need to combine. I don't know what that looks like yet. I agree.
So along that note, I mean, if in your path determination, do you take and between 2 hops go, okay, I see on the other side, I'm coming out here. What does it look like coming, trying to determine other than just where the traffic is going, trying to find a way from what's this, say hop 3, what's this hops 3 best way to get to hop 4 and not trust how it's actually getting routed?
Yeah, that's quite a challenge. I don't know. I think that's really, I'll have to spend some time thinking about that.
Yeah, if I had like access into the routers and looking at BGP, it'd be, go to router 3. How does it think it needs to get to the actual physical IP on the other side rather than just how does this packet get?
You almost need awareness of the full topology and then see the path, like what scope of the topology does the path comprise, and then is there a better, shorter path, not based on what the protocols think, but based on our analysis of how much latency or packet loss is imposed on each link and node. I'll have to think about it. Yeah, very cool. Okay, well that's all I have. Thank you guys.
Thank you, Chris.
Thank you.